Hello everyone. So this is a question from NEET 2025. Which of the following aqueous solution, very important, will exhibit the highest boiling point? Okay. So they have given us four solutions. So this is very important that it is an aqueous solution. That means in all four of them the solvent is going to be water. Okay. And also they are asking us about the boiling point, so we need to know what is the meaning of boiling point. Okay, so boiling point is the temperature at which vapor pressure of liquid becomes equal to the atmospheric pressure. Very important. Okay, so boiling point is temperature at which vapor pressure of liquid becomes equal to the atmospheric pressure. Okay, and one more point regarding boiling point that is very important is boiling point of solution is always higher than the boiling point of the pure solvent. Okay, that is boiling point of solution is always more than the boiling point of pure solvent. Okay, and this increase, can you see the solution has more compared to the solvent? So this increase of solution compared to the solvent is known as elevation in boiling point. Okay, this increase is known as elevation in boiling point. And if you want to see the rough sketch of vapor pressure versus temperature, if we draw a rough sketch of vapor pressure versus temperature, so the solvent curve looks something like this and the solution curve looks something like this. So I will write solvent here, I will write solution here, and let's say this is the value of 1 atm, which is the atmospheric pressure, right? So you can see this is the point in the curve. This is the temperature at which vapor pressure of the solvent is equal to the atmospheric pressure. So this temperature is the boiling point of the solvent. So I will represent them like this. So this temperature is the boiling point of solvent. So we represent it by TB naught, right? And you can see this is the curve of vapor pressure versus temperature of the solution. This is 1 atmosphere. You can see for the solution at this particular temperature the vapor pressure is equal to 1 atmosphere, right? So this is the boiling point of the solution. So let us represent that by TB. And as I mentioned already that boiling point of solution is more than boiling point of solvent, so therefore you can see TB is more than TB naught, right? So this difference, that is TB minus TB naught, is known as delta TB, which is known as elevation in boiling point. And since elevation in boiling point is a colligative property, so we know that delta TB is equal to I into KB into M, right? Where this I is the Van 't Hoff factor. Okay, so this I is the Van 't Hoff factor, and in case of dissociation, I is the total number of ions produced from 1 mole of solute. Okay, so in case of dissociation, I is the total number of ions produced from 1 mole of solute. Okay, then we have this KB. KB is the molar elevation constant of solvent. Okay, KB is molar elevation constant of the solvent. This is very important. If you have taken, in this question we have taken aqueous solutions, so therefore the KB value will be same for all of them because the solvent is same, and for water it is 0.52. okay, and this M, small m, is the molality of the solution. Okay, so M is molality of the solution, right? One more thing that we need to remember is whenever we take non-electrolytes, for example sugar or urea, so these guys won't dissociate into ions. they don't undergo any dissociation or association in solution. Okay, this is an important point. That is, non-electrolytes like glucose or urea, they neither dissociate or associate in the solution. Okay, and one more thing that we need to know is, whenever we have a very dilute aqueous solution, okay, very dilute aqueous solution. So when I say dilute, that means the amount of solute is very less and solvent is huge in amount. And aqueous solution, that means the solvent is water. Molarity is approximately equal to molality. That is, capital M is approximately equal to molality. So both can be used interchangeably. Okay, so that is because since it is a very dilute solution, the amount of solute will be very less. So therefore, total volume of solution will be equal to the volume of solvent, right? So we can write total volume of solution will be approximately equal to volume of solvent, because just now I mentioned that it is a very dilute solution. So amount of solute is very less. So approximately total volume of solution will be equal to volume of the solvent. And we know that density of water is 1 gram per centimeter cube, or it is 1000 kg per meter cube, or 1 kg per liter, right? So this is the density of water. So can you see from this unit, 1 liter of water has mass of 1 kg, right? Because the density is 1 kg per liter. So I can write 1 kg of water, or it will be better if we write 1 liter of water has mass of 1 kg, right? So therefore, let's see what is molarity and molality. Molarity is number of moles divided by volume of the solution, right? So let us say the volume of solution that I have taken is 1 liter. Molarity is again number of moles divided by mass of solvent in kg, right? So numerator same, numerator same. Denominator is volume of solution 1 liter. So since it is a very dilute solution, we can say it is volume of water 1 liter. Mass of solvent in 1 kg. So it will be same. 1 liter will contain 1 kg. So therefore, the denominator term in molarity and the denominator term in molality are the same. And obviously numerator is same because number of moles are same. So therefore, we can say that molarity is approximately equal to molality in a very dilute aqueous solution. Okay. So therefore, using these facts, we can proceed. And so we know that delta TB is equal to I into KB into M. And delta TB itself is TB minus TB naught, which is equal to I into KB into M. So TB is TB naught plus I into KB into M, right? So this TB naught is the boiling point of the solvent. So in this case, we have water. So it is going to be 100 degrees Celsius. So it is a constant. So TB naught is a constant for all the 4 cases, because in all 4 cases, the solvent that we are using is water, right? So therefore, we can say that this TB actually depends upon I, KB, M, because this is constant for all of them. Okay. So I can say that TB is actually directly proportional to I into KB into M. And if you remember, I mentioned that this KB is the molar elevation constant for a solvent. And in this case, again, the solvent that we're using is same. So therefore, this will be 0.52 for all of them. Or I can say that TB is actually directly proportional to the product of I into molality, right? And just now I told for a very dilute solution, molality is approximately equal to molality. So therefore, I can write ultimately TB will be directly proportional to I into the molarity. So using this information, now we can look into the options one by one, right? Option A is 0.01 m Na2SO4. So you can clearly see this guy is an ionic compound. So therefore, it will undergo dissociation, right? So it will dissociate to form Na2SO4 will dissociate to give us 2Na plus and SO4 minus 2. So I will be obviously 3. How? Because I mentioned, if you remember, I is the total number of ions produced from 1 mole of the solute. So you can see 1 mole of solute sodium sulfate will give us 2 and 1, 3 ions in total, right? So therefore I is equal to 3. So therefore TB will be directly proportional to 3 into molarity is 0.01, or you can say TB is directly proportional to 0.03. Okay, cool. Next, option B. Option B, we have 0.015 m C6H12O6. So this is glucose, and glucose is a non-electrolyte as we have discussed. And for non-electrolyte, it neither undergoes association nor dissociation. So I will be equal to 1. So therefore, so therefore TB will be directly proportional to 1 into the molarity, which is 0.015. So TB is directly proportional to 0.015, right? Cool. Option C, we have 0.01 m urea. Okay, so urea is again, a non-electrolyte. It has the formula NH2CO NH2. Okay, so it is a non-electrolyte, so therefore I will be again equal to 1. It neither undergoes association nor dissociation, so therefore TB will be directly proportional to 1 into the molarity, which is 0.01. so TB will be directly proportional to 0.01. And the last option is D. We have 0.01 mole KNO3, and KNO3 is an ionic compound, and therefore it will undergo dissociation or decomposition. So KNO3 will give me K plus and 1 NO3 minus. So therefore I will be equal to 2, because 1 mole is giving me 2 moles of ions, right? So therefore TB will be directly proportional to I into the molarity. So 2 into and molarity is 0.01, right? So therefore TB will be directly proportional to 0.02, right? Now they are asking us which one will exhibit the highest BP. Obviously, the number to which TB is directly proportional, that will decide. The highest number will obviously give us the highest boiling point. In case A, we have 0.03, then we have 0.015, which is smaller, 0.01 is even smaller, and D is 0.02. So therefore, this number is the highest number. So therefore A will exhibit the highest boiling point, that is 0.01 m sodium sulfate. Okay, so therefore A is the answer. This is the answer. Okay, thank you.